All right, section 6.1 feels like such a short section. It's a nice way to start the chapter. There's some really long sections in chapter 6, so let's be grateful for this. Each of the problems between 1 and 10 are really 4 problems in one, so they're kind of 40 problems instead of 10 problems. And I'll just jump into it, starting with 2a. 2a, we get a symbol that I'm going to read as find f composed with g of x. And to do f composed with g of x, this means to find f of g of x. So that open circle can be replaced with essentially a couple parentheses. I can kind of delete that open circle, that means composition, and change it to 2 parentheses. And that is supposed to be something that makes this problem easier. Because to do f of g of x, I'm going to take in the f function, and I'm going to replace the x with g of x. Because f of anything, you change whatever you're taking f of to that what you're taking f of. So f of g of x is just going to be 4 times g of x minus 5, because f of g of x is going to be 4 times g of x minus 5. I'm just changing the x to g of x. Now I'm going to change the g of x to 5x minus 7. And I'm going to get f composed with g of x is 20x, by clearing the parentheses that I have here, 20x minus 28 minus 5. My answer to part 2a is f composed with g of x is going to be 20x, which is the first term, and the last 2 terms combined to be minus 33. Done with part A, on to part B, when there's not a lot of work to do. To find the domain of a composite function, you need to take the domain of the first function, the function that's written to second, and somehow integrate it with the function that's written first. Both functions in problem 2 are polynomials. They're actually lines. The domain of every polynomial is negative to positive infinity. And when you compose 2 functions that have domains of negative to positive infinity, that's going to be the domain of the composition. When I first shot this video, this is a reshoot, I did a super long explanation, and then as I watched it back, I thought that explanation was kind of only maybe for me and somebody that really wanted to go pretty high in mathematics. And so for our problems, the parts B and D of numbers 1 through 10, if neither f nor g are fractions, because and if they're polynomials, the domain of any polynomial is negative to positive infinity, or all real numbers. So for problems 1 and 2, because both f and g are polynomials, we're just going to say the domain of f composed with g is negative to positive infinity. We won't do any algebra. If you want a better explanation of why that domain is negative to positive infinity, come visit me in my office, and I'll give you as long of an explanation as you'd care, as you can handle. But like I said, when I watched it back, I wasn't so happy with my explanation. It's not that it was incorrect, but it was kind of above what most students would want to tolerate. So I'm done with A and B. I'm going to move on to part C. Part C asks of number 2, wants me to find g composed with f of x. And again, this composition, I can replace the composition with a couple of parentheses. This is going to be the same as asking me to find g of f of x. And to find g of f of x, I go to the g function and I change the x in the g function to f of x. So this is going to be 5 times f of x minus 7. Could put that f of x in a parentheses, it probably would be nice. And now I'm going to change the f of x to 4x minus 5. So I'm going to get 5 times 4x minus 5 minus 7. And I get g composed with f of x. I'm going to simplify this by clearing the parentheses, multiplying 5 times 4x and getting 20x, 5 times minus 5 and getting minus 25, and then I have the minus 7. The answer to part 2c, g composed with f of x, is equal to 20x, and I'm going to combine those terms and get minus 32. For 2d, that wants me to find the domain of g composed with f of x. Because both g and f are polynomials that have domains of negative to positive infinity, the domain of g composed with f of x is also going to be that, and it won't need any algebra to be solved. So that might help you get through problems 1 and 2. If it doesn't, I'll do problem 3 and 4, and then maybe it'll inspire you to do 1. All right, so for problem 4, both functions f of x, it's a parabola, which is a polynomial. G of x is a line, which is a polynomial. Both functions f of x and g of x have domains of negative to positive infinity. So when I go to answer the domain parts, the part b of number 4 and the part d of number 4, because each of the functions f and g are polynomials, one's a parabola, the other is a line. When you compose two functions that have domains of negative to positive infinity, you get a domain of negative to positive infinity, and there's really no algebra you can do, so there's really nothing I could do in explaining that's going to be turn a light bulb on for you. So let me do parts A and C. 4b and 4d, there's no algebra to do. Both f and g are polynomials, so the domain of the composition is f composed with g is negative to positive infinity, and g composed with f has a domain of negative to positive infinity. 4a wants me to find f composed with g of x, and that really is the same as f of g of x. So what I'm going to need to do is, in the f function, change that x to a g of x. So I'm going to write f composed with g of x equals, and then that x gets changed to a g of x, so it's going to be g of x squared plus 2. Now I'm going to change the g of x to 5x minus 1. So I'm going to get f composed with g of x equals 5x minus 1 squared plus 2. And to finish up part 4a, I just need to simplify that right-hand side by clearing the parentheses and combining like terms. To clear the parentheses, I'll write it without the exponent and I'll FOIL it. When I FOIL it, I'll do firsts are 5x times 5x and get a 25x squared. Outers are 5x times minus 1, which is a minus 5x. Inners are minus 1 times 5x, which is a minus 5x. Last are minus 1 times minus 1, which is a positive 1. And then I still have this plus 2. My answer to part 4a, or at least an answer that's going to be acceptable for a test, is f composed with g of x. The first at 25x squared I'm going to leave alone. The outers and the inners I'm going to combine to be a minus 10x. And the constants at the end I'm going to combine to be a plus 3. I don't believe that factors. I'm not even going to make a stab at factoring that. That would be nasty bottoms-up factoring that I want to get into. So the answer to 4a, f composed with g of x, is 25x squared minus 10x plus 3. For part C, to do g composed with f of x, g composed with f of x is the same as g of f of x. And to do g of f of x, I need to replace in the g function that x with an f of x. So g composed with f of x is going to be 5 times f of x minus 1. I just changed that x to an f of x, and now I'm going to change the f of x to x squared plus 2. So g composed with f of x is going to be 5, and then I'm going to change the f of x to x squared plus 2, and then I still have the minus 1. I'm going to clear the parentheses, and this parentheses is a lot easier to clear. When I clear the parentheses, I go 5 times x squared is 5x squared, 5 times 2 is plus 10, and then I have the minus 1. The answer to part C, g composed with f of x, is going to be 5x squared plus 9 because the last terms here combine to be a 9. So still at the easy-ish problems because each of the functions, f's and g's, are polynomials. In a few problems here, the f's and g's are going to become fractions, and then everything gets harder because fractions have restricted domains. There's numbers that need to be excluded from the domain of the fraction. Then everything's going to get harder. So give number 3 a go. I'll move on to the next page and give 5 and 6 a go. So for both 5 and 6, the f function is a line which has a domain of negative to positive infinity. The g function is a parabola. The graph of it's a parabola, which has a domain of negative to positive infinity. When you compose two functions that have domains of negative to positive infinity, you get a function that has a domain of negative to positive infinity. So the answer to part B and part D, when we're finding the domain of each of these, is negative to positive infinity. When I go to do part 6a, I'm going to find f composed with g of x. And I know that means to find f of g of x. And so that means in the f function, to change that x to a g of x. So that's going to be g of x minus 3. I just changed that x in the f function because the f function is written first. That tells me to go to the f function, change its x to g of x. And now I'm going to change the g of x to x squared minus 4x minus 2. I didn't put this g of x in an extra parentheses because that x doesn't have an exponent or a multiplication associated with it. And when I replace the g of x with x squared minus 4x minus 2, because there isn't a number in front of it or an exponent associated with it, I really don't have to put that in a parentheses. So for an answer to number 6a, it'd be completely fine if you just wrote f composed with g of x equals, bring down the x squared, bring down the minus 4x, and combine the last two numbers. Those are both negative. I'm going to add them and keep them negative. I'll call this an okay answer. Any problem that you get an answer with a square that's obviously factorable, if it takes seconds to factor, it's better to factor it. And I'm going to factor this. This factors into x plus 1 times x minus 5. If you don't notice the factoring, and I ask you a question like this on the test, probably on your, I know on your answer I'm not going to take points off. I would just probably write the factored version next to the unfactored version if you don't factor it on a test. All right, so part D of problem 6 wants me to find the bad one, g composed with f of x, and that's going to be g of f of x. That requires me to change that x and that x to an f of x. So g composed with f of x is going to be equal to, that x gets changed to an f of x. The f of x needs to go in a parentheses because the exponent of 2, then the minus sign, and then the 4, and that x gets changed to an f of x. Again, the f of x has to go in a parentheses because of the 4 in front of it, then the minus 2. Now I'm going to change the f of x's to x minus 3 and get g composed with f of x as x minus 3 squared minus 4 times x minus 3 minus 2. And now I just need to do the algebra to clear the parentheses and combine like terms. The first thing I'm going to worry about is the x minus 3 squared. I'm going to rewrite that as x minus 3 times x minus 3 and FOIL it. First are going to be x times x, which is going to be x squared. Outers are going to be x times minus 3, which is going to be a minus 3x. Inners are a minus 3 times x, which is a minus 3x. Lasts are minus 3 times minus 3, which are plus 9. When I do the foiling, the outers and the inners are going to combine. And after I get the foiling done, I'll get x squared minus 6x plus 9. So that's clearing the first parentheses. To clear the second parentheses, I'm going to go minus 4 times x, which is going to be a minus 4x. And I'm going to go minus 4 times minus 3, and that's going to give me a plus 12. So I squared by foiling the first parentheses. I distributed the negative 4 through the second parentheses. I still have this minus 2. I almost have something that's suitable for an answer for g composed with f of x. That's the answer to 6D. I'm going to bring down the x squared. I'm going to combine the minus 6x and minus 4x. Because the numbers in front of the x's are both negative, I'm going to keep those numbers negative. And then the last numbers, 9, 12, and minus 2, I'm going to combine. 9 plus 12 is 21. 21 minus 2 is positive 19. And in my answer, I'm going to write this, and I'm pretty sure this is prime. This is actually my answer. I'm actually working on 6C and not 6D here, because the domain was actually 6D. So the answer for 6C, which is prime, that doesn't factor, is x squared minus 10x plus 19. I did this video recently, and I don't remember any of the answers, which is really kind of unfortunate. So give 5 a go. And once we get beyond 5, the next 4 problems, 7, 8, 9, and 10, both the f's and the g's are fractions, or at least one of the f's or g's is a fraction, and we've got many, many more issues to do. So when I move on to 7, 8, 9, and 10, bad things happen. So I can't jump right into doing the domain, because the domain of f of x, you'd set the denominator equal to 0 and get x equal to negative 4. And your f of x, the domain is all real numbers except negative 4. And your g of x, to find the domain, you'd set the x minus 7, the denominator equal to 0. You get all real numbers except 7. Because the domains of the functions aren't negative to positive infinity, the domains of the compositions won't be negative to positive infinity. So for my function f, just real quickly, I'll write down the domain of f of x is all real numbers except 6. Algebraically, I would just take the denominator and set it equal to 0 to get that 6. That's going to be important in one of the answers that we come up with in a bit. And for g, if I was trying to find its domain is going to be all real numbers except negative 1. Because both the f and the g have domains that aren't all real numbers, the domain of the compositions are going to have numbers to exclude. So when I go to get started, I probably need lots of room. So I'm going to do each of the parts on a separate sheet of paper. So I jump into 8a. 8a wants me to find f composed with g of x. To find f composed with g of x, that's going to be f of g of x. And I need to replace the x in the g function, in the f function, with g of x. And so that's going to give me f composed with g of x equals 1 divided by, I'm going to change that x to a g of x. It technically doesn't need a parentheses because the x doesn't have an exponent, nor does it have a number multiplied by it. So I'm going to write just the g of x minus 6. Now I'm going to replace the g of x with 1 over x plus 1. So I'm going to get f composed with g of x equals 1 over x plus 1 minus 6. That is a monster to work on, so let's just deal with it. I'll worry about the domain later. The best thing you could do before you get way bogged down is to change this problem from a triple layered fraction into a division. What I'm going to do is put the entire denominator in a parentheses and put it after a division sign. So I can rewrite the problem so that it's not a 3-layered fraction, that it's just the numerator divided by a fraction. The stuff that I have from the denominator in the parentheses, I need to really clean up, meaning I need to get it down to one fraction as opposed to this subtraction. To do that, I'm going to write the 6 as 6 over 1, and I'm going to multiply it by x plus 1 over x plus 1. So what I'm going to get on this next line inside the parentheses is I'm going to make it so the two fractions can be subtracted. The first fraction I'm going to leave 1 over x plus 1. I'm going to leave the minus sign, and in the second numerator I'm going to write 6 times x plus 1 and then over x plus 1. So what I've done is made this into a fraction and gave it the denominator it needed to have. Now, inside that ugly parentheses, the two fraction can be made into 1. So I'm going to write it as 1 minus 6 times x plus 1 over x plus 1. So I've taken these two fractions and subtracted them. And now I'm going to work on the numerator. The numerator has a 1 and then a parentheses. When I clear that parentheses, I go minus 6 times x and minus 6 times 1. That numerator is going to turn into negative 6x minus 5 because this 1 and that minus 6 come out to be minus 5. But let me just write this down in multiple steps just in case you need to see it. So I'm going to have 1 divided by 1 minus and then 6x minus 6 over x plus 1. That's what I get when I clear this parentheses. And now, in the numerator of this fraction, the 1 minus 6 is negative 5. So this is going to give me f composed with g of x equals 1 divided by, it's going to be minus 6x minus 5 over x plus 1. This is a lovely, lovely place to be because now I have a division. And when you're dividing by fractions, you can make that division into a multiplication. So I can rewrite this as f composed with g of x equals 1 times, and when you're multiplying by a fraction, or you're dividing by a fraction, you can flip it and make it a multiplication times the reciprocal. Now 1 times anything is itself. This could be an okay answer right here. So an okay answer to part A would be f composed with g of x equals to x plus 1 over negative 6x minus 5. Completely fine. I don't really need to do anything with it. But if you wanted to, a better answer for part A of number 8 would involve factoring out a negative 1 from the denominator . That would be better. You could actually move that negative up to the numerator, but that's going to start getting ridiculous. So one version of this would be my answer for 8A. Either that without the negative factored out from the denominator, or with the negative factored out from the denominator. There's even more things I can do, but then this is just getting silly doing so much more. Now we need to move on to 8B and find the domain of f composed with g of x. I'll tell you how to do it and then I'll explain how to do it. So there's two stages to this. To find the domain of f composed with g of x, step 1, find any numbers that need to be excluded from the function that's written second in the original problem. In this problem, the second function is g of x. The g of x is 1 over x plus 1. The number that needs to be excluded from the domain of g is negative 1. So one of the numbers that I'm going to have to exclude from my domain is negative 1, because the function that's written second is g of x equals 1 over x plus 1. The number that gets excluded from the domain is what you get when you take the denominator and set it equal to 0. You get x equal to negative 1. This is going to be one number that's going to need to be excluded from the domain for my answer of part B when I go to find the domain of f composed with g of x. This is because if at the very first version of my problem, if I plug negative 1 in for x right here, then I'd plug a negative 1 in for that x, and I'd get a fraction that had a 1 in the numerator, negative 1 plus 1, which is 0 in the denominator. I'd get an undefined fraction. So I can't plug negative 1 into the initial version of the problem without getting, I get undefined. It turns out that if I plug negative 1 into this other version of this problem, the simplified version, The numerator would be negative 1 plus 1, which is 0. The denominator would be negative 6 times negative 1 minus 5. That turns out to be 1. That's not undefined there. So I can't plug negative 1 into the initial unsimplified form of the answer, so that number needs to be excluded from the domain. There's another number, and there's another step here to define the domain of a composition of fraction. The second step is to find any number that needs to be excluded from the domain of the answer. And one of my final answers, I'm going to do the okay answer. One of my final answers, one of the simplifications of it, was x plus 1 over minus 6x minus 5. If I put a value in for x here to make that denominator 0, I'm going to get undefined. So any number that makes this fraction's denominator 0 needs to be thrown out of the domain also. I'm going to get that number by taking the denominator of my final answer and setting it equal to 0. To do that, I'm going to add 6x to both sides. That will give me negative 5 equals to 6x. And then I'll divide both sides by 6 and get negative 5, 6 equals to x. So this step gives me one number to exclude from the domain. The other step gives me a number to exclude from the domain. The domain of this fraction, f composed with g of x, is going to be all real numbers except negative 1, the number that makes the function that's written second undefined, and negative 5, 6, the number that makes the answer undefined. So as I go to write an answer for 8b, the domain of f composed with g of x is all real numbers except x equal to negative 1 and negative 5, 6. All right, so I'm going to go through and maybe let me do a little bit with your number 9 or your number 7. Just instead of doing C and D on mine, let me walk through 7 with you all the way so that you're not feeling completely left out. So let's walk through 7 together. If you want to pause the video and try number 7, that would be great, but you don't have to. So I'm going to do 7a as opposed to doing 8c and d. 7a wants me to find f composed with g of x. I know that that means to find f of g of x. And that means to go to the f function. Your f function is 2 over x plus 4, and to change the x to g of x. So f composed with g of x is going to be 2 over g of x plus 4. The g of x doesn't need to go into parentheses because the x doesn't have an exponent or a multiplication. Now I'm going to change the g of x to 3 over x minus 7. So I'm going to get 2 over 3 over x minus 7 plus 4. All right, now I'm going to do this. Remember how we did this? We made this into a parentheses and rewrote this with a divide sign. So f composed with g of x can be written as 2 divided by 3 over x minus 7 plus 4. And you'll notice I wrote that 4 a little bit high because I need to make this 4 into a fraction and multiply it by x minus 7 over x minus 7. So I found a very unsimplified version of f composed with g of x that kind of have this multi-layered fraction. I changed a multi-layered fraction into a division, and I'm going to take this 4 and write it over 1 and multiply it by x minus 7 over x minus 7 so that I have two fractions with the same denominator. This is going to give me f composed with g of x equals 2 divided by 3 over x minus 7 plus 4 times x minus 7 over x minus 7, because now I just did the multiplications there, made that fraction, these two fractions have the same denominator. This is going to give me f composed with g of x equals 2 divided by 3 plus 4 times x minus 7 over x minus 7. These two fractions have the same denominator. I can make them into a single fraction. Now I'm going to work on that numerator. I'm going to clear the parentheses by going 4 times x and 4 times minus 7. That numerator is going to come out to 3 plus 4x minus 28. So I'm going to get f composed with g of x equals 2 divided by 3 plus 4x minus 28 over x minus 7. I'm going to combine the like terms. 3 minus 28 is negative 25. This is going to give me f composed with g of x equals 2 divided by, parentheses, 4x minus 25 over x minus 7. On to another sheet of paper. And on this other sheet of paper, I'm going to change this into a multiplication. So this is going to be f composed with g of x equals 2 times x minus 7 over 4x minus 25. And this is really 2 over 1 times this. So I'm going to multiply 2 times the numerator, and I'm going to leave it factored, and get 2 times x minus 7 in the numerator, and multiply 1 times the denominator. 1 times 4x minus 25 is 4x minus 25. This is as nice of an answer to 7a as I can get. That's what f composed with g of x is in a nice kind of reasonably simplified answer. To do part B, to find the domain of f composed with g of x, first I find any number that needs to be excluded from the letter that's written second, and then I find the domain of the answer. So to move on to part B, for 7b, I'm finding the domain of f composed with g of x. So first, find all numbers that need to be excluded from the domain of g of x, because that's the function that's written second. In our problem, g of x is 3 over x minus 7. So since our g of x is 3 over x minus 7, the number to be excluded from the domain you get by setting the denominator equal to 0. That's going to give me x equal to 7. That's one number that's going to need to be excluded from the domain. And then second, we find all numbers that need to be excluded from the domain of the answer. And the answer is that ugly fraction. To find the number that needs to be excluded from the domain of a fraction, you just take the denominator and set it equal to 0. For this one, I'll add 25 to both sides and get 4x equal to 25, and then I'll divide by 4 and get x equal to 25 over 4. The numbers that need to be excluded from my domain for my answer to part 7b are 7 and 25 over 4. For my answer to part 7b, I'm going to say the domain of f composed with g of x is all real numbers except x equals 7 and 25 over 4. It's a monstrous problem. I generally don't ask these on the regular in-class test. If you wind up missing the test and having to take a makeup test, I sneak those on the makeup test. Let me do 7c and 7d. Kind of out of paper here. Wow. So, whoops, that's 9. Oh gosh, there's still, okay, there's a lot more in this section. Let me jump on and do 7c. 7c wants me to find g composed with f of x, which is going to be g of f of x. To do that, I'm going to, in the g function, I'm going to replace that x with an f of x. So g composed with f of x is going to be 3. That x is going to change to an f of x, so 3 over f of x minus 7. And now I'm going to change the f of x to that horrible fraction. So g composed with f of x is going to be 3 over 2 over x plus 4 minus 7. That's just taking the f of x and changing it to what it's equal to. Now it's just all algebra, so ugly algebra. So g composed with f of x equals, put this in a parentheses, write it as a fraction, 3 divided by 2 over x plus 4 minus 7. Write this 7 as 7 over 1. Multiply it by x plus 4 over x plus 4. This is going to give me g composed with f of x equals 3 divided by 2 over x plus 4 minus 7 times x plus 4 over x plus 4. I'm going to make the two fractions into one and get g composed with f of x equals 3 divided by 2 minus 7 times x plus 4 over x plus 4. Now I'm going to clear the parentheses in the numerator and get g composed with f of x equals 3 divided by 2 and then minus 7x and then minus 14 over x plus 4. Now I'm going to combine like terms and get minus 7x minus 12 in the numerator. This will give me g composed with f of x equals to 3. And then in the numerator, I just need to subtract the 2 minus 14 and get a negative 12. So it's going to be the negative 7x I didn't circle is going to be first. The 2 and the 14 subtract to be a minus 12 that I circled becomes second. Almost done with part C. I need to make this division into a multiplication. So I'm going to make that division into a multiplication by flipping the fraction after the division sign. So I'm going to get 3 times x plus 4 over negative 7x minus 12. I'm going to think of the 3 as 3 over 1, and I'm going to multiply this and this, and I'm going to get an answer, and I'm not even going to take the time to factor out a negative from the denominator. In the numerator, I'm going to write 3 times x plus 4, which you could multiply and make 3x plus 12 if you want to. In the denominator, 1 times anything is itself, so I'm going to write minus 7x minus 12. And I'll consider this an answer to part 7C. 7D wants me to find the domain of g composed with f of x. I do this in 2 stages. First, find all numbers to exclude from the domain of the function that's written second. The function that's written second is f of x, and in our problem 7, f of x is 2 over x plus 4. To get the number to exclude from the domain, I take the denominator of that function and set it equal to 0, and I get x equal to negative 4 to exclude from the domain. And then second, I find all numbers to exclude from the domain of the answer. The answer I have boxed up there. To find the numbers to exclude from the domain, we just simply set the denominator equal to 0. Maybe I'd add 7x to both sides and get negative 12 equals to 7x, and then divide by 7. Get x equal to negative 12 over 7. The numbers that I need to exclude from the domain in my answer for part D of number 7 are negative 4 and negative 12 sevenths. So I'm going to say for my answer for part 7D, the domain of g composed with f of x is all real numbers except negative 4 and negative 12 sevenths. I've never asked one of these on a test that wasn't a makeup test, so only the beginning problems that are polynomials are something you really have to worry about. We're really deep into this video, There's still a problem 9 and problem 10. I'm going to vote that we just skip these. This is finding domains of composites where both functions are fractions. Let's go ahead and skip 9 and 10. If you wind up having to take a makeup test over this chapter, you want to sit with me and make sure you learn how to do those. But if you're not taking a makeup test, just the first few problems that ask me to find the f composed with g in the domain, the g composed with f in the domain, where the f's and the g's are lines and parabolas, are all you're responsible for. So we just have 2 questions left, but each one has a part A, B, A and B. And these are proofs, and that's not the best thing for most students. The instructions say, show that f composed with g of x equals to x and g composed with e of x equal to x. In part 12a, it could really just say find f composed with g of x, and you've made a mistake if your answer is anything other than just the single letter x. Similarly, 12b could be written find g composed with f of x, and your answer, I'll just say something a little bit shorter, is wrong if it isn't just x. So when it says show that f composed with g of x equals to x and g composed with f of x equals to x, it just means to find f composed with g of x and to find g composed with f of x. And it's trying to help me out. It's trying to tell me what answer I'm expecting to get. And the answer that I'm expecting to get is x for both of those. So I'm going to just go straight through and do 12a. So 12a, I just need to find f composed with g of x. And I know that f composed with g of x is f of g of x. That's pretty easy for me to do. F composed with g of x. I'm going to take the f function and I'm going to change that x to a g of x. So that's going to be 3 minus 4 times g of x. I hope like heck that this simplifies just to be plain ordinary x. If it doesn't, I've made a mistake. Next step is going to replace the g of x with 3 minus x over 4. So this is going to be 4 times 3 minus x over 4. And the beautiful thing is, I can think of this 4 as a 4 over 1, and I could cancel these 4s as I go to simplify. And when I cancel that 4, there isn't anything but 1s in the denominator. I don't need to write a fraction anymore. So f composed with g of x, after I cancel the fractions, is going to be 3 minus, cancel this 4, not cancel this parentheses, but cancel the denominator of the parentheses. It's going to be 3 minus parentheses 3 minus x. And now I'm going to clear the parentheses. When I clear the parentheses, this negative is going to make that 3 a negative. And it's going to flip the sign of that x to positive x. So I get 3 minus 3 plus x. And that gives me f composed with g of x equals to x. So I've proved what I needed to do. My instructions were to show that f composed with g of x equal to x. You do that by finding f composed with g of x. Your answer is right if you get x for an answer. Your answer is wrong if you get anything other than the single letter x. So that's 12a. I'll move on to 12b and find g composed with f of x. To find g composed with f of x in 12b, I'm supposed to know that g composed with f of x is the same as g of f of x. So that means in the g function, to change that x to an f of x, the minus in front of it forces me to put a parentheses. So I'm going to write g composed with f of x equals 3 minus parentheses for the f of x. Then I'm going to I'm going to put an f of x in where the x is, and then over 4. So to do g of f of x, I change the x to f of x, put it in a parentheses because of the minus. And now I'm going to do g composed with f of x, and I'm going to change the f of x to 3 minus 4x. So I'm going to get 3 minus, and then inside of parentheses, 3 minus 4x over 4. And now I'm going to do the algebra to clear the parentheses by changing the signs. The minus sign in front of the parentheses, when I clear the parentheses, will make that a minus 3. It'll flip that sign to a plus 4x. So I get 3 minus 3 plus 4x over 4. That's going to give me 4x over 4 because the 3's are going to cancel. And now the 4's are going to cancel. And I'll get g composed with f of x equals to x. That's what I need to happen for problem 11 when you go to do it. When you do part A, you're supposed to find f composed with g of x. And when you find f composed with g of x, if it equals to x, you did the work right. If it equals to something other than x, you did the answer wrong. Similarly, when you do question part B, you find g composed with f of x. If it equals x, you did it right. If it doesn't equal x, you did it wrong. When I look at 13 and 14, they look different enough. I'm going to do 13 just so you don't have to stumble through the math just in case it's hard. Pause the video if you want and just watch me do it after you've done it. 13a, I'm going to find f composed with g of x. And I know that means f of g of x. So in the f function, I'm going to change that x to a g of x. It doesn't really need to go in another parentheses because that x doesn't have a multiplication or an exponent or a minus in front of it. So I'm going to write f composed with g of x. I'm going to change that x to a g of x. So it's going to be g of x minus 5 over 2. And now I'm going to replace the g of x with 2x plus 5. So I'm going to get f composed with g of x equals 2x plus 5 minus 5 over 2. These 5's cancel, so I'll get f composed with g of x equals to 2x over 2. 2's cancel, makes it so I don't need the fraction, and I get f composed with g of x equals to x. That's exactly what I needed to do. The instructions said show that this equals to that. I show it by finding it. I'll sneak part B right next to this. Hopefully it fits. So for 13b, I need to find g composed with f of x, which is g of f of x. To do that, in the g function, I change that x to an f of x. So this is going to be 2 times parentheses f of x plus 5. So that's going to give me g composed with f of x equals 2. And then in that parentheses, I'm going to put x minus 5 over 2 in place of the f of x. And I think of this as 2 over 1 times that, so that the 2's will cancel. There's 1 in the numerator, there's 1 in the denominator. I cancel the 2's. That's going to make this g composed with f of x equals the first parentheses. Now I can just write it as x minus 5. I've canceled the fractions. I've canceled the number in front of it, so I don't need a fraction anymore. I really don't need even the parentheses anymore. I can just drop that parentheses and get x minus 5 plus 5, and that's just a lonely x. And that's what I needed for each of the last 4 problems, 11, 12, 13, and 14. They had 2 parts, and in each of the parts you find what's left to the left of the equal sign. The answer has to be to what's to the right of the equal sign. All right, that's got to be enough for this section. We have some really long sections, so give yourself some extra time as you go through Chapter 6.